Welcome, dear viewers, to another roller coaster ride through the mind-blowing marvels of our universe. Prepare to be dazzled as we journey from the infinitesimal to the infinitely large, from the fleeting flicker of time to the timeless puzzles of existence. We'll delve into the enigmatic corners of the human brain and grapple with the paradoxes that have kept philosophers and scientists awake through the ages. This isn't just a journey through facts and figures, but a voyage of discovery that transcends the boundaries of what we know and pushes the frontiers of our understanding. So fasten your seatbelts, keep your mind open, and let's embark on this thrilling expedition. First stop, the startling world of the smallest. Ever wondered what the tiniest things in our universe are? Well, buckle up, junior investigators, because today we are diving headfirst into the wild world of the itty-bitty. Our grand adventure begins at the bottom of the universal barrel with a tiny fella known as the Planck length. Now this guy is smaller than a speck of dust on a flea's backside. It's so teeny, in fact, it's 20 powers of 10 smaller than the diameter of a proton. Seems like a tough concept to grasp? You bet! At this size, gravity and space-time throw a tantrum and quit, and quantum shenanigans take over. Next, we're going to shimmy on down to the atomic nightclub, where subatomic particles like quarks cut a rug. These teeny-weeny particles are so small that they're basically the zeros of particle physics. Quarks come in 6 funky flavors: up, down, charm, strange, top and bottom. It's almost like they've got their own lingo. These quirky quarks always stick to their friends, a habit they call color confinement. Now, moving away from the lifeless to the living, say hello to the tiniest biological raver, the nanoarchaeum equitans. This microscopic maestro, discovered in a hot tub off Iceland's coast, is just 400 nanometers across. That's 100 times smaller than a grain of sand. Yet this pint-sized wonder has its own DNA and is a full-fledged living being, capable of growing and making copies of itself. The world of small is as crazy and captivating as the world we see every day. Every tiny particle, every microorganism plays a mean game in the grand playground of the universe. They may be small, but boy, do they pack a punch in our understanding of the cosmos. It's pretty wild, right? The tiniest things in our universe are true head spinners. But it's time to give our microscopes a rest and jet off into the grand, wide macrocosm. From the smallest, we now journey to the largest. How vast do you think our universe is? Picture for a moment, if you will, a grand cosmic arena that extends beyond the limits of our human comprehension. This is our universe, a staggering expanse that contains everything we know and everything we have yet to discover. Let's start with the basics. The size of the observable universe, that's the part of the cosmos we can detect from Earth, is estimated to be about 93 billion light-years in diameter. Now let's put that into perspective. If we were to travel at the speed of light, which is approximately 186,000 miles per second, it would still take us 93 billion years to traverse from one end of the observable universe to the other. And within this vastness there are galaxies, estimated to be as many as 2 trillion of them. Each galaxy is a cosmic city, teeming with stars, planets, and perhaps life forms. Our very own galaxy, the Milky Way, is just one among these, housing somewhere between 100 billion to 400 billion stars. Now, if your mind isn't already spinning, consider this. Each star in the Milky Way could potentially host a solar system with planets. Imagine the multitude of possibilities, the uncountable worlds that could be out there, each with its own story, its own history, its own secrets. We've been talking about the observable universe, but what if our universe is just one among a multitude? The concept of a multiverse suggests that there could be an infinite number of universes, each with different physical laws, different histories, and different outcomes. The universe's vastness is almost unimaginable, but we're just getting started. Brace yourself for more mind-boggling facts. We've traveled across scales, but now let's delve into the realm of time. Is time absolute or relative? In our daily lives, we tend to think of time as a constant. The seconds tick by, every minute is 60 seconds, every hour is 60 minutes. But in the broader universe, time is a much more flexible concept. Enter Albert Einstein, the man who changed our understanding of time forever. His theory of relativity introduced the world to the concept that time is not absolute but relative. What does this mean? Well, simply put, the passage of time can change depending on your speed and the force of gravity you're experiencing. Imagine you're on a spaceship traveling near the speed of light. To you, inside the ship, time seems to pass normally. You could watch an entire series of your favorite show and it would feel like the usual binge watching. But what about to someone back on Earth observing you? For them, time aboard your spaceship would appear to slow down. Your binge-watching session might take centuries in Earth time. This is what's known as time dilation. Even gravity can bend time. The stronger the gravitational pull, the slower time passes. So if you were to hang out near a black hole where gravity is incredibly strong, time would pass slower for you than for someone far away from the black hole. You could age a few minutes while decades pass elsewhere in the universe. It's a mind-boggling concept, isn't it? That time can stretch and squeeze, that it's not a constant stream but a flexible river shaped by speed and gravity. It's a concept that challenges our everyday experiences and understanding of the world. So, time is not what it seems, but wait, there's more. We've only scratched the surface of the mysteries of time, so stick around as we continue our journey through the fascinating world of mind-blowing facts. Let's shift our focus inward now. What do you know about the most complex structure in the universe, the human brain? No larger than a 2-pound loaf of bread, the human brain nonetheless holds within its folds a staggering complexity. It's a veritable universe of cells and connections, an intricate and delicate powerhouse of activity. This phenomenal organ possesses around 100 billion neurons, the nerve cells that transmit information. This number is roughly equal to the number of stars in the Milky Way galaxy. But the wonder doesn't stop there. Each of these neurons can connect to thousands of others, forming a network of connections that numbers in the trillions. In terms of sheer computational power, the brain outstrips any supercomputer. It's estimated that the human brain operates at approximately 1 exaflop. That's 1 billion calculations per second. To put that into perspective, it'd take a line of people stretching from Earth to the moon and back, all counting together, over a month to match what your brain does in a single second. And yet the brain is not a static, unchanging structure. It's a dynamic, adaptable organ exhibiting a property known as neuroplasticity. This means that the brain has the ability to reorganize itself, forming new neural connections throughout life. It can adapt, learn, and even heal, responding to new experiences, learning, and injury. This incredible adaptability allows us to learn new skills, recover from brain injuries, and adapt to new environments or changes in our environment. It's the reason you can learn to play an instrument, master a new language, or adapt to a sudden change in your life. So, within the confines of our own skulls, we carry an entity of extraordinary complexity and adaptability, a testament to the remarkable capabilities of nature's design. The human brain, a marvel of nature, is an enigma in itself. But let's not stop here. So tune in for our next exploration into the paradox of existence. Finally, let's ponder over the biggest question of all. Why does anything exist at all? This question is so profound that it has been at the heart of philosophical and scientific debates for centuries. What is existence? And why is there something rather than nothing? Philosophers have wrestled with this conundrum for millennia. Some suggest that existence itself is an illusion, a construct of our minds. Others argue for a more concrete reality, but one that is fundamentally inexplicable. We can describe the how of existence, how matter interacts, how life evolves, but the why remains elusive. Scientists, too, grapple with the mystery of existence. Physics, for instance, seeks to explain the nature of the universe. Yet, even as we delve into the subatomic world of quantum mechanics or the vast expanses of cosmology, we find more questions than answers. Why do particles behave the way they do? Why does the universe have the structure it does? These queries lead us to the ultimate scientific goal, the theory of everything. The theory of everything, or the grand unified theory, is the holy grail of physics. This theory aims to combine all the fundamental forces and particles of the universe into a single, coherent framework. Yet, even if we achieve this, would it explain why there is something rather than nothing? Perhaps not. Perhaps the mystery of existence is beyond the scope of human understanding. Maybe it's a question that doesn't have an answer, or at least not one we can comprehend. But that doesn't mean we should stop asking. Questions are what drive us, what push us to explore and discover. Our existence is indeed the greatest paradox. As we end our journey, remember, the more we learn, the more mysteries we uncover. So keep wondering, keep questioning, because the quest for understanding is the most exciting journey of all.